A mirror with a focal length of negative 50 centimeters creates a 10 centimeter long image with an image distance of negative 30 centimeters. Determine the object distance, magnification, and the length of the object. Okay, so we are going to use the optic formula here. 1 over the focal length equals 1 over the object distance plus 1 over the image distance. So we know the focal length. The focal length is negative 50 centimeters. And I want to take a moment here to mention that I know a lot of times they say go ahead and convert your centimeters to meters. In this case, when you're using the optic formula, so long as all three of these are going to have the same units, you don't need to convert. So in this case, I know my focal length, it's in centimeters, my image distance is in centimeters, so there's no need to convert. That means my object distance is going to come out in centimeters. Also want to take a moment to point out that the focal length is negative. That tells me that this mirror is a diverging optic. It's a diverging mirror, which also means that it's convex. Because diverging mirrors are convex. There we go. Which means they bulge outward. Okay, so continuing on here, we don't know the object distance. That's what we're solving for. And the image distance is negative 30 centimeters. Okay, so this becomes negative 1 over 50 minus negative 1 over 30. Those minuses cancel and become positive. That equals 1 over dO. Now, we could get the common denominator. In this case, it's actually not too difficult to go ahead and do it that way. But in general, that's not always going to be the case. So my recommendation is to go ahead, grab your calculator, and crunch the left side here. Let's crunch the numbers. And if I do that, I get 0.01333, it's a 3 repeating. And that's going to equal 1 over the object distance. Now, I can't stress this enough, we are not done. All we have solved for here is 1 over the object distance. We still need to solve for the object distance. The easy way to do that is to take the reciprocal. When I did this calculation just now, I left the number in my calculator. And I hope you did as well. It makes it easier here because now all you have to do is take the reciprocal of your answer. On your calculator, that's going to be x to the minus 1. That's how it is on my calculator. Or it might be like 1 over x. So if you just hit that button, it should take the reciprocal of your previous answer. And when I do that, then it comes out to be 75 centimeters. That's the object distance. Now, a couple things. Notice that the image distance was negative. That's not a surprise. That tells me it's a virtual image. And the reason it's not a surprise is because diverging optics can only make virtual images. But my object distance came out positive. Also not a surprise. We're dealing with a single optic device. We only have a mirror. And in those cases, the object distance is always positive. So if the object distance had come out negative, that would tell you that you'd made a mistake. All right, so now let's determine the magnification. We have two formulas for magnification. The negative of the image distance over the object distance, and we also have the image height over the object height. We're going to end up using both of these, but first, since we're calculating the magnification, we don't know the object height yet. That's actually one of the things we need to solve for. So we're going to use this one first. We know the image distance and the object distance. It's going to be straightforward to get the magnification. So we take the negative of negative 30 over 75, and this works out to be 0.4. There aren't any units. They cancel out. This is negative 30 centimeters over 75 centimeters, so the centimeters just cancel out. No units, and this is the absolute value is less than 1. That tells me that the image is diminished. So this is the magnification. I should also point out the magnification came out positive. Because the magnification came out positive, that tells me the image is upright, and that's not a surprise either because it's a virtual image, and virtual images are upright. Now we can figure out the length of the object because we know the length of the image. So moving over here to this formula, magnification is 0.4. The image height, I'm putting the image height in as positive. It's actually 10 centimeters. That's important because this is a virtual image, because I know it's a virtual image because my image distance is negative. With single optic devices, virtual images are upright, and thus the convention is that HI is positive. So I put it in as positive 10. If we had a real image, if we had a positive image distance, that would mean we had a real image. I'd have to put the image length in as negative because it would be inverted. So just solving for HO here, oops. So the length of the object, that's going to be 10 centimeters divided by 0.4, and that just works out to be 25 centimeters. And the object height came out positive. It has to come out positive. Again, we're dealing with single optic devices, so our object heights are always going to be positive, just like our object distances, always going to be positive. And that's all there is to this.